Hi, and welcome to the 2018 Paper 2 Junior to Higher Level Question 4. And as usual, okay, if you want to set these notes I'm working off, send me an email at shanetroy@gmail.com, and that email address should be in the description below. And again, I always suggest you pause the video and try the question yourself, and then if you're stuck or just to check the answer, flick on to the next page that has the answer. Okay, now let's have a go through. This is obviously a probability question, okay, as it says probability. So this guy or girl, okay, person, takes part in a chess competition. In each game, so establish gender at least, although there's no marks of that. In each game, she can win, we represent that with a W, draw a D, and lose an L. In each game she plays, each of these three outcomes is equally likely. Okay. Write down the probability that Hagar wins her first game. Now, probability, I often just think back to the simplest one, okay, which is the case of flicking a coin. So if I said, what's the probability of getting a heads on a coin? Okay, I might say, well, how many things could happen when I flick a coin? Well, there'd be two, wouldn't there? Okay, how many things will happen? Okay, only one. So it's a 1 in 2 chance of flicking a heads. Now, in this scenario, okay, now that's basically gives me the probability formula. In this thing, how many different things could happen? Well, there's 3. How many things will happen? There's 1. You either win, lose, or draw. There's no overlap. There's no win-draw or draw-lose. So the probability of winning is 1 out of 3 options. That's that. Okay. Now, part B here, now part A and B are marked together. Okay, so you're asked to fill in the table below to show the 9 possible outcomes from Hagar's first 2 games. 1 is already done, okay, and LW stands for she loses game 1, so loss, then wins game 2, loss, win. Now, this is ridiculously easy, okay. This, in essence, is a sample space, okay, and it's representing everything that could happen from playing game 1 and game 2. So I'm just going to go to the answer and have them prettier, okay. So you see here I have the formula for probability, okay, but now can very barely see that, but that's loss, win. Now that was the one we were given, okay. So she could win game 1, win game 2, win game 1, draw game 2, win game 1, lose game 2, okay. She could draw game 1, win game 2, draw game 1, draw game 2, draw game 2, draw game 1, lose game 2. This is a tongue twist. She could lose game 1, win game 2. We've given that. Lose game 1, draw game 2, or lose game 1, lose game 2. That's all that can happen. There's nothing else that can happen. And again, that's a sample space. So it's fairly handy. Okay. So part A and B, 10 marks. The probability is one of these things, like anything else, it takes practice. Unfortunately, I've just recently done this question out, and the easy bit ends. Okay, so we're on to part C now. Now C has 2 parts, part 1 and 2, and they're marked together. Again, we're 10 marks. And we're into advanced probability here. So it says find the probability that Hagar wins game 1 and loses game 2. Okay, there's a hint there, and I have it written up here. If you're winning game 1 and is the word. Now they say it there, just don't highlight it. Okay. Now in probability, the and scenario means you multiply. The or scenario means you add. So there's 2 events here, okay? Probability of game 1 and game 2. So whatever the probability of winning game 1 is, she's going to multiply that by the probability of losing game 2. And when I first did this out, I thought it was win game 1 and win game 2. But that's my one problem with maths is I never quite read the question properly in my hurry to show my excellence. I copied it, obviously. So let's go to the answer here just for simplicity. Now, ignore the bottom bit for now. The probability of her winning is 1 in 3. Now, the probability of her losing, okay, a game is also one of the 3 possibilities. Okay. So the probability of winning game 1, which is 1 in 3, and, which means multiply, losing game 2, which is 1 in 3. So 1 in 3 times 1 in 3 gives you the answer. Okay, now win and, I even made a mistake here. Now, so it's probably of win and lose. Okay, Now, just with the last little bit of an explanation on this is each one of these games is what's called an independent event. Like, you could argue this, winning game one is not going to affect whether you win or lose game two. You could argue confidence and all that kind of stuff, but they're both different scenarios. The same thing when you toss a coin. The second time you toss it, just because you got heads the first time doesn't mean you're more or less likely to get heads the second time. It's still a new event, and it's independent of all the other events. And it's a good concept to keep a handle on in probability, because there are dependent events where and that's where you get to very advanced probability. So anyway, I use the calculator. A third by a third, shouldn't need to, is a ninth, and I just use the calculator then to turn that into a decimal. Now, the question doesn't ask you do it in either way. I'm just giving both just to show the difference. Okay, but it is worth pointing out that probability is always scored between 0 and 1. So if you got an answer greater than 1 or negative, it can't be an answer. Okay, the only time you get an answer bigger than 1 is if you turned it into a percentage by multiplying by 100. Okay, so that's part 1. I'm going to go back just to declutter. So part 2 here, it says, find the probability that Hager wins at least one. At least one. Again, that's highlighted for a reason, of her first 2 games. Now, I've given a hint here because this is fairly complicated stuff. Okay, if you think it through and write out each thing, it gets easier, but that takes time. Okay, so if she wins one of her first 2 games, she has to either win the game and win the second game, or win the first game, lose the second game, lose the first game, win the second game. Read through that and make sure you make sense. Okay, but I've covered every option. In all of those scenarios, she wins at least once. Okay, now there should be scenarios where she wins twice. Okay, the top one there, she wins twice, because that's why it says at least once. Now, if we look back at the sample space from the answer in part B, okay, she wins once, she wins once, wins once, wins once, and wins once down there. Doesn't win in any of those other options. Now, there's 9 possibilities. Okay, how many of them did she win once in? At least 5 of them. And that's basically your answer. Okay, so now I've done it out here slightly differently. Okay, in the more classic probability way. Okay, that one worked out nicely because we had the sample space done. It's a small enough thing we can do it by hand. But we're basically asking here in this question, what's the probability of winning at least one of first 2 games? Okay, we said that. Okay, now that's the probability of winning and winning. Okay, and that was a third by a third, which was a ninth. Okay, 1/9. Okay, or means add. Okay, winning and losing. Or it could have been winning and drawing, or it could have been losing and winning, or it could have been drawing and winning. But each one of them is the same thing. It's a third by a third, okay? A third by a third, a third by a third, a third by a third. So that's each one of them represented there, okay, in that calculation. Now, I'm adding them, okay, because it's the OR scenario in between. So third by third is a ninth plus a ninth plus a ninth plus a ninth plus a ninth is 5 ninths. Okay, which turned to decimal is 0.55. Now, which was easier? This. Okay, now you didn't need to write all this out, but I'm doing it so hopefully if you're reading back it makes sense. Okay, or copying that you could use the sample space that you arrived at back here, or even just writing them all out. Okay, whatever way you get to it, ultimately the answer is the answer, okay? But probability is one of these things that practice just makes perfect, okay? But even if you're practiced, it can be what's called counterintuitive. Sometimes the answer is the opposite of what you think it is, which makes it hard to predict if you're right or wrong, or do you have any confidence really? And this is very simple probability. Now, part D here says Hager plays 3 games in the competition. So they've upped the ante here. It was 2 games up to now. And says work out the total number of different possible outcomes for her 3 games. Now there's different ways of approaching this as well. Okay, the simplest would be to literally physically write out all of them. Okay, and I've kind of done that here. Okay, so I've gone like, if you start with the first letter, she wins the first game always. Then she could win, 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 lose, win, win, draw, win, draw, draw, win, draw, lose, win, lose, win, win, lose, lose. You know, you could keep going that way. And then do the exact same thing again, except she's drawing the first time. Do it all again, she's losing the first game. Okay. Now there's 9 outcomes in that winning first, plus 9 in drawing first and 9 in losing first. Okay, 9 plus 9 plus 9 is 27. Sorry, I've written here. Now, doing it with a more formulaic way, okay, is basically saying, like, she could win, okay, and all the other scenarios, just lose or draw in the first event as such. There's 3 outcomes from that, but there's 3 different events. So in the first event, there's 3 outcomes, and second event, so it's and means multiply. 3 times 3 times 3 gives you the 27 from a kind of calculating way. Now that's part 1. Okay, now part 1 and 2 are marked together now. It's only worth 5 marks, so you know this is tough. The last part here is probably the tougher thing again. But part 2 says work out the probability that she doesn't win any of her games, any for 3 games. Now this took me a fair bit of while. Okay, I kind of have the sample space done up here. Now I didn't finish it off that way, just because space or whatever. It might just get too cluttered and scare you away. But if I plucked out all the ones without a win, with no basic W in them, after having all these 27 written out, I'd have ended up with these 8. Okay. So what's the probability she didn't win any of the games? It's 8 out of the total 27 possible outcomes. So it's 8 out of 27. Now there is other ways of doing that. Not quite sure if I get most of them. Okay. This just seems more obvious way of doing it. Okay. But again, there's 27 different outcomes happening. The letters all look the same. It can drive you demented trying to make sure you haven't said something already. Being systematic and organized helps to draw out this kind of large sample space. And then if you have the large sample space done, you can just pluck out answers. But that's easier said than done. So anyway, that's question 4. Okay, so I'd suggest going back over it again because and trying it again yourself. But it is probably is a hit and miss kind of game. Sometimes it's lovely and easy like part A and B. And then sometimes it devolves into fairly complicated stuff. Anyway, thanks and see you on question 5.